Hello everyone. The title of this presentation is Extracting Insight by Clustering Structured Data, which is the paper for CR 2021. My name is Amir Rouhi. I work at RMIT University in Melbourne, Australia. My job title at the moment is data analyst, and I'm handling a project as a project planner in College of Business and Law. My education background is I have a PhD in computer science in information retrieval. My hobbies is meditation, camping, and motorcycle. All the institutional entities, I mean some entities such as students and courses, consist of different attributes such as student IDs, levels, program code and name, course code and name. These information are stored in the Relational Database Management Systems, which we call them RDBMSs, and in form of tables and records. Breaking down the concept of the entities and their attributes and storing them into tables is called normalization. The problem is that in what extent can this cliché structure negatively impact on researchers by limiting their views to the institutional data? The objective of this research is to introduce a new lens by which to analyze structured data with the aid of clustering algorithms. To achieve this objective, the attributes of different entities can be merged using classical database views. Before we embark on the conventional analysis of the extracted data, we can apply an unsupervised machine learning algorithm or clustering to detect a hidden correlation among the attributes and thereby regroup the data points into new clusters in order to start the analyzing process. This can assist institutional researchers to distill different perspectives of data and to extract invaluable insight based on the automatically detected clusters. So what's the ultimate question of this research is there any similarly behaved groups of data beyond their conventional categories in the structured tables in our databases? And what is the final objective is the process of finding those hidden groups. I call them insights. In this slide, I try to show you the methodology and compare the structured data versus clustering by these images. On the left, we have tables consist of rows which are called records, and we have related tables or joined tables, which is the characteristic of RDBMSs. On the right, we look at the data as a basket, like all of the items in the tables are all those different objects in the baskets, and we ask machine or clustering algorithm to categorize them or cluster them based on different attributes for us automatically, like color, shape, and size. In this slide, methodology shown by a series of different images from bottom left to top right. The first step is the extracting data from structured databases in form of views, and finally you have your data in the form of a spreadsheet or table. Then you have to apply some pre-processing over the data to make it ready for clustering, because clustering cannot be applied over categorical data. You have to change them to numerical data, and then after that you apply the clustering algorithms based on different clusters, and you have to do this cycle, pre-processing and applying clustering, and finally you find the best or final appropriate clusters that can answer your question. And then the interpretation and extracting insight is the most important level, which needs a lot of expertise and time to understand how the machine categorizes the data in this way. This is the first example of utilizing clustering to cluster programs based on their AQF level, which is the certificate, undergrad, postgrad, and based on their FCEL load to complete, like 1 year, 2 years, 3 years. So the issue was related to the load forecasting. In that project, we should categorize the programs together. So just structured tables shows us the undergrad or postgrad programs with 2 years or 3 years or whatever you want. But the question is that, is there any other lens, any another aspect of the programs that may categorize an undergrad program with a postgrad program because of similar behavior, or a sub-degree program with an undergrad program because their behavior are similar. A structured database cannot find these things. So I try to find, is there any similar behavior in these levels or not? In the continue of example 1, I try to show here that the three parameter that I use for clustering, which is the aggregate average aggregate load that needed to complete a program. For example, 0.5 means half year, or 2.3 means more than 2 years. AQF level of the program, which is from 1 to 10. 1 is a certificate and 10 is a PhD. And sector of the program, which is 1 for HE and 2 for VE. As I said, we have to change the categorical data to numeric. And this slide is the last slide for clustering programs example. I try to show you how the clustering could cluster different AQF level of programs in one cluster, or different program from sectors in one cluster. On the top left and top right diagram is a two-dimensional chart. The x-axis shows AQF level, and the y-axis is the total time or FCEL needed to complete the program. And as can be seen, some of the columns are consist of multiple colors, which means that AQF level consists of different clusters. All of these ones are categorized as one in the structured database. But here, for example, in AQF 7, we can see 1, 2, 3, 4, and 5 different clusters, which is fantastic, characterized by distinguished by the computer. In the lower chart, I try to show three-dimension diagram by adding the sector. So you can see AQF level in y-axis, sector in x-axis, and the total FCEL needed to complete the program in the z-axis. In spite of separating 0 for VE and 1 for HE, two main group of clusters, but some of the programs, like pale blue, are appeared in VE and HE, which means that they behave similarly. These are the fantastic results that only can be recognized by clustering. In a structured database, you cannot distinguish them. This is a second example of utilizing clustering to show you. I try to show you how increasing the number of clusters can give you more insight. Three different dimensions based on the load or FCEL of the program has been utilized in this analysis. Past FCEL is the total number of subject load that the student passed in a specific year. Certified is total taken by the student. For example, 8 subject is certified and 7 of them passed. And cumulative past FCEL is the total subject that the student passed from beginning of his education career up to now. So based on these three, I utilized 3 clusters, 4 clusters, and 5 clusters. You can see that the clusters in the bottom left and top right of the charts, three-dimensional diagrams, are steadily showing two specific groups, but the middle part, by increasing the number of clustering, is disintegrated from 1 to 2 and then to 3. It means that the first cluster on the bottom left and top clusters on the top right are more stable and they clustered, and increasing the number of clustering does not have any significant impact on them. But the middle class can be disintegrated to the lower level of clusters. This is the third and last examples of clustering. I try to investigate the behavior of the programs based on their pass, fail, and withdrawal rate for 2 different sectors separately, VE and HE. Bottom left shows the VE programs, and X, Y, and Z. 0 means, for example, for pass, 0 means no pass, 1 means pass. For fail, 0 means no fail, and 1 means fail. And withdrawal, 1 means withdraw, and 0 means not withdraw. So, as can be seen, there is a cluster of the VE programs shown in the green color that they show a very high withdrawal and low pass rates. It would be very insightful for the program managers to get the list of these programs and investigate why these groups of programs are behaving similarly. Please consider that these programs are coming from different AQF levels, and 3 different attributes are considered to cluster them together. You cannot easily extract this data in this insight from structured data. But on the HE on the right, you can see the students are more prone to pass and low fail and lower withdraw compared to HE. And however, there are a group of programs all clustered in the orange color. The withdrawal rate among them is higher in the early with the lower pass. There are some recommendations when using clustering to analyze data. For example, which clustering algorithm? The algorithm I use is k-means, but there are different, which is very common, but there are different algorithms. I provide you the reference for different clustering algorithm at the end of this slide. The most significant one is changing the categorical data to numerical data to enable them to utilize clustering. There are 2 categorical data, big groups, ordinal and nominal. Ordinal one are easily convert to numerical data. For example, for excellent, good, and bad, you can give the number 3 for excellent, 2 for good, and 0 to bad, or fantastic, okay, or don't like. But for nominal, one of the approach is using one-hot encoding. I use in this in my research. For example, you have nominal data, pen, pencil, and eraser. So you consider 3 columns. If the record shows pen, you select. You put the first column 1 and the other 2 columns 0. If it is pencil, you put the first column 0, second column 1, and third column 0, and so on. So you can one-hot encoding increase the number of columns, but it cope with this kind of nominal problem in clustering. In conclusion, I want to inform you with respect to the limitation of structured data and the unavoidable exponential growth of institutional data. Utilizing machine learning algorithms is a bonus to overcome these barriers. Unsupervised machine learning algorithms can analyze and cluster unlabeled dataset. These algorithms, such as clustering, enable us to step further and go beyond the limitation of structured data. They are capable of automatically measuring the distances and grouping the data points into new clusters without human interference. This research is just a sample of the clustering techniques applied to student program data and resulting challenges. However, it can be applied on any level of institutional entities such as course level data, human resources, equity groups, finance, and etc. Finally, the three essential skills which enable us when dealing with structured data to perform the insight extraction process successfully are accessibility to subject matter experts, SMEs, for extracting appropriate data, data pre-processing before applying clustering algorithm, and finally selecting the appropriate clustering algorithm. Moreover to the references provided in the paper, two references I provided here for you for clustering methods and clustering numerical and categorical data, how to cope with this issue for clustering. Finally, for the impact of a study, I can grab your attention to some of the potential areas that can utilize the clustering techniques, such as HR groups, student performance analysis. However, the current application for the clustering in our university is in major and minor student load forecasting. The challenge of the forecasting is assigning a major or a minor to a single program. However, there are common courses between different programs. We plan to use clustering to select the most appropriate program for each major and minor, and we are at the middle of this project and I'm leading this project now. Thank you for your attention.